Okay, I'm back. Um, I'm doing my best to not sound sick. All right, this is the last graphing piece you need to do. The amplitude is stretching it vertically. The midline or vertical translation moves the whole thing rigidly up or down. And right now we're going to learn how to, instead of going to 360 or 2 pi, how to make it go whoop, the same 5 dots, 0 max, 0 min, 0, only in a shorter distance, or to stretch it out into a longer distance. So you still only need those same 5 spots. We're just figuring out where the zeros are, that's the midline, how high they go, that's the amplitude. But before that, now we have to figure out, do they go all the way to 2 pi, or do they only go to pi, or do they go to 4 pi, or same thing with degrees? That's what you're learning right now. I'm going to try to talk a little bit faster and share my screens so that we can do this together. But the reality is, you can stop and start this video. I still am uncomfortable doing it. I don't feel really good, but I'm trying to empower you as though I were there teaching. So here we go. We are going to do this. And this time I'm going to keep myself on the screen a little better so that if I'm gesturing, you'll be able to see it. All right. This is the most recent Jamboard that we loaded up today. And basically the idea here is we are going to be working on how to adjust that period. The period means how long does it take to fit those 5 critical points, the pattern, 0 max, 0 min, 0, or cosine max, 0 min, 0 max. The question is, where do those start and stop? So that's what you're learning today. You know everything else already. All right. We already know the A is for amplitude, that stretches it vertically. We already know the D, that's where your 0 line, your midline, your 0 line goes. And now we're going to say this, if this is not 1, then that period from where the first to the last of the 5 points is either shorter or longer, depending on what the B is. So the next slide in this Jamboard is going to give you an important formula that you must write down in your journals as soon as I just pause it, as soon as I get to this page, and write this down. Do not ignore me. Okay, I'm assuming that you paused and you're starting it back up now and you wrote it down. First, you need to figure out and or decide if you are in degrees or radians. So if you are in degrees, then you use the formula 360 degrees divided by whatever the B is. So the B is going to help us determine, the B is not how long is the period, the B is going to help us determine how long the period is. So if we are in radians, then you take 2 pi divided by the B. So that is how you find the period. You must use this, one of these formulas. Okay. So if these so if these were my notes, I would write everything here down, and then I would draw a big box in my notes around it so that I could find it easily and know right where, because you can't move forward on graphing the period without it. Okay, so next page. All right, so here's what we're going to do. This one says, find the period of this equation. And then it tells us right here that they want to know it in degrees. So that's the first question. Find it in degrees and then find it in radians. And so that's your job, right? So in this case, A is 3, right? D is -5, right? Neither one of those affect the period. This is the amplitude. And this tells us the vertical translation. We already know how to do those. But we notice, right this minute, we notice that the B is no longer 1. There's a number that's nestled right in there inside this parentheses. It's right tucked in here, and it's right in front of the angle. That angle could be a theta, it could be an X, but this is the B. There it is. For the first time, it's not 1. So in order to find the period in degrees, we take the 360, that is the normal period, and we divide it by the B, and we go, oh, so now we know that the period of this graph in degrees is 180 degrees. That means it's slinkied shorter. It's going to go, what a cosine, max 0, min 0, max in 180 degrees instead of the 360. That's what that means. All right. So now if we're going to do this in radians, okay, in radians, well, what's the full period in radians? 2 pi. The B is 2, right? So we take 2 divided by 2. That means that we go max 0, min 0, max at pi. But guess what? We already knew that because pi is the same as 180. It's not different. What's the B? The B is 2. That's what we're doing. Okay, pause it, adjust your notes. Here we go. All right, so this is different. This is saying basically they haven't given us an equation. They've given us a graph. So we go, this is weird. So here's how you do this. You look at this graph and you look very first. The first place you're going to look is at the y-axis right here. And you say, look at here is where the graph starts. Does it start at 0 or does it start at a maximum or minimum? Sorry. So the fact that it starts at 0, we know it's going to be a sine function. So we write that, and then we say 0 max. So now we know it's going to be a positive coefficient. And then it goes back to 0, back to the minimum, and back to 0. Stop, because now we know that's one full period, those 5 points. So you say to yourself, okay, one full period stops right there. All right, that's what we need to know. That's what they're asking us. One period says, how long does it take to follow the pattern? 0 max, 0 min, 0. Okay, so now we have to kind of erase here and say, well, where is that? I'm looking, where is it actually? Oh, it's at 180 degrees. So you say, okay, well, we stop there because that's where it is. It is 100. The answer is 180 degrees is equal to the period. That's how you do it. How long is the stretching like a slinky or shortening for it to accomplish the full pattern? So we went 0 max, 0 min, 0, and that took us 180 degrees to accomplish that. All right, let's look at the next one. All right, so again, we start at the y-axis and we say, wait a minute, where does it start? Oh, it starts at the maximum, then it goes to the 0, then it goes to the minimum, then it goes to the 0 line and back to the maximum. Because it starts at a max or min, we know it's a cosine. And we know that it has to follow the max, zero min, zero max pattern, unless it's got a negative lead coefficient, and then it's flipped from that. Same with sine. It could be flipped over, reflected is what I mean. All right. And so then we have to figure out, well, yeah, but how long did it take us to get there? And you go, oh, well, this is where I finished. I went max, zero, min, zero max. And then I just look and go, wait, that took us until 4 pi to finish it. Therefore, the period, how long it stretches to get those 5 critical points of the pattern in, the period is 4 pi, because that's how long it took. Okay, pause, take notes, do whatever you need, and we are going to do 2 of these, and all they're asking us is what is the period of these 2 functions, okay? So I'm going to talk you through this. The amplitude is 2, not what they're asking, but it is 2, okay? The vertical shift is nothing. There's no, plus 0. There's no vertical shift. But the b is 1/2. B is equal to 1/2. Therefore, because it's not 1, the period is not 360 or 2 pi. It's something else. So they want it in degrees. So we're going to do this. We're going to plug in the 1/2 right there. So we take 360. You could do this on your calculator if you don't like fractions. 360 divided by 1/2 is the same as 360 divided by 1/2, which you flip and multiply. 360 times 2/1, which means it's really stretched out longer to 720 degrees. So I'm just going to give you a little spoiler alert. If the fraction is less than 1, between 0 and 1, the period stretches. And if the number is bigger than 1, the period reduces. I think it's 1. Anyway, okay. The period shortens. All right, here we go. How do we look at this graph and know what's happening? Well, I notice here's my max, 0, min, 0, max. All right. How far did it take us to do one pattern of whatever the pattern is, either cosine or sine? This one happens to be cosine because I start at max, 0, min, 0, max. And we get to the period that those 5 points are accomplished at 2 pi over 3. And so that is the period. We don't know what the b is. We'd have to solve for b, but that's the answer to the question of what the period is. All right, so now we're going to put it all together. Okay, here we go. We're going to notice that we are in radians. That's great. The amplitude is 2. The midline is at y equals -7. It's a sine, so it goes, and it's a positive coefficient, so it's 0 max, 0 min, 0, and all we have to do is find out the period. Now we know that b is equal to 4, and we're in radians. So I'm going to take 2 pi divided by 4 and simplify. 2 goes into 4, so that simplifies to pi over 2. So my period is pi over 2. Now, I'm going to show you quickly how to graph that because it's tricky. Are you ready? Not that tricky, but it's tricky. Please watch the Jamboard. Okay. You are going to, let's see, what's the amplitude is 2. Okay, so we're going up. Oh, midline is -7. Oh. All right, I'm going to go and, all right, we'll try it here. -7. All right. 1, 2, 3, 4, 5, 6, 7. So there's my midline at -7. Okay. I know the amplitude is 2, but importantly, I know that the period is pi over 2. So I'm just going to pick a spot right here that says pi over 2. And I need 5 points. The first one is at 0. Okay. So I need to have my 0. And then I need the 3 points in between 0 and pi over 2. So what's half of pi over 2? Is pi over 4. And half of all I'm doing is taking pi over 2 and multiplying by 1/2. And that's how I get pi over 4. And then I take pi over 4 and multiply by 1/2, and I get pi over 8. That's pi over 8. And this is 3 pi over 8. So I've got my 5 critical points, and I go 0. Amplitude is up to, back to 0, back down to, and back to 0 at pi over 2. And I put this graph right in there. That's how you're doing it. It'll start to click, but you've got to pay attention to keeping track of your information here. You have to write those down before you start doing anything. You have to figure out what you know and what you don't know. All right, here we go. Amplitude. I'm looking here and I go, well, remember how we talked about the range kind of thing in that Desmos for the 13 of you who did it. So it looks like the maximum right here is at 3 and the minimum is at -5. So 3 plus -5. No, well, that'll give me my amplitude, but I don't like formulas. I like looking at them. But anyway, how far is it from 3 to -5? That's 8, right? And 8 divided by 2 is 4. So the amplitude is 4. So you're going to count down 1, 2, 3, 4. Here is your midline, halfway between the max and the min. So now we know y equals -1 is the midline. The period, we're starting at 0. Max, 0, min, 0, max. Ooh. Do you see what I just did? I made a mistake. The zeros aren't at the zeros are at the midline. Max, 0, min, 0, max. Okay. And it stops right here at 180 degrees. And the amplitude we already said was 4. Okay. The amplitude is 4. That's it. That's how you do it graphically, and that's how you do it with an equation. Okay, let's find again. Amplitude. What I'd like you to do is to write these down or look at them and try to fill in the information, and pause the video and then keep watching. Okay, but this is going to be so long already. I got to keep going. Amplitude is -6. Vertical translation is y equals 3. Period is degrees. So 360 divided by 3 is 120 degrees. Cosine makes, cosine, but alert. Okay, alert. Negative cosine. Or excuse me, negative lead coefficient. So it's got to reflect. So instead of starting out at the maximum, you're going to start out at the minimum, 0, maximum, 0, minimum, because it is a reflected cosine. Okay, that's all the information. On number 2 here, you should have already tried it. Your maximum is at 5, your minimum is at -1. So the distance between the two is 6. Cut that in half. The amplitude is 3. Let's see. So 1, 2, 3. It looks like the midline is right here. I go 0 at the midline. max, 0 is always the midline, minimum 0. So it's obviously a sine. The period stops at 4 pi. The midline is at y equals 2, and the pattern is 0 max, 0 min, 0. Okay. On the next slide on the Jamboard, pause it. Those are the step-by-steps. And here we go. Okay. It's not too bad. I'm going to walk you through step by step. The amplitude is the absolute value of -2, which is +2. Alert, remember, it's going to be reflected. Okay. The period is degrees. So the period is always 360 divided by the b, which is going to be 360 divided by 3. So the period is 120 degrees. The midline is y equals -1. It's sine and it's negative, so it goes 0 minimum, 0 maximum, 0 because it's reflected, -a. All right, so here's how you do it. The first thing, I usually start out with the period, and I put 120 degrees there. Zeros here. We know that we're going to divide our period into these 5 points. So zeros, the first one, 120, half of 120 is 60. Half of 60 is 30. 3/30 is 90. There they are. There are 5 critical points. Now we just graph how we know. So y equals -1. This is our midline right there. What's our amplitude is 2, and we're reflected. So we're going to start out with 0, and we're going to go to the minimum, down 2, back to the 0 midline. Then here we're going to go up 2, back to the 0. And there it is, a reflected sine curve. I think the biggest piece is you have to find your period, and then you find halfway. And then you cut that in half again, or a fourth of the way, quarter of the way, or however you want to think about it. And then you do 3 of those to get there. So basically, you just are cutting it into fractions, which are not what you guys feel most excited about. Okay, one more, and then I think this is the last one. Okay, we're now in radians. So here we go. This one's a little trickier because it's got fractions. I'm going to probably argue that if we ever put these on tests, we'll keep it in degrees because it's a little easier fraction work for you. Amplitude is 3. Sine, the period, let's see, midline is y equals 0 because there's no d added in. The period is 2 pi divided by 1/3, which is the same as 2 pi times 3/1, which is 6 pi. Okay, you can do that on a calculator if you just wanted to take 2 pi divided by parentheses 1/3 if you feel uncomfortable with the fractions. It's a positive sine curve. 0 max, 0 min, 0. Okay, where do you start? You start right here with the period. Start here. Start with the period. 6 pi. Cut that in half. What's half of 6 pi? 3 pi. And then if you don't know how to cut that in half, you just put 3 pi divided by 2, and then you get 3 of those, which is, I don't know, 9 pi divided by 2. If you don't get all of those labels, it's not the end of the world. As long as you know 6 pi and 3 pi, probably good enough. And the amplitude is 3. So this is your max area, your min area, your midline is at 0. It's a, what do we have, sine? So I'm going to go 0, max at 3 pi over 2, 0, min 0, and it keeps going, but there you go. Okay, so that is basically the idea. Hopefully you stopped and paused and took notes. And then the next thing I want you to do while you are in class today is to open up the Desmos that's linked there and go play around with the period shifting. And then Mr. Harker has left a homework. I think we're calling it, I know I got the numbers off to match him. It just became easier with me being out sick. So go ahead and then take that homework and try to put it all together and apply it. And then we'll go from there. All right. Good luck, kids. I have filters on this video. I look better than I feel, but that's all right. If you're going to make a video, you might as well do it. Mr. Callahan, if you would be so kind as to help them get that Desmos link that's on the agenda, and kids do the Desmos, and then after you finish the Desmos, you can show Mr. Callahan you finished the Desmos, and then he can give you the homework to work on. All right, be respectful, be kind. I miss you guys. I do not choose to not be there. Okay, bye.